So this is a little video about squares and square roots. You've probably seen this symbol before, which is saying to find the square root of 4. But why do we call it a square root? Why not just call it a 2 root? And if you think about it, it's because we're really asking, in a visual sense, the question of, I have a square with an area of 4, 1, 2, 3, 4. What were my side lengths? What times itself equals 4? And in this case, I know that answer. I know that 2 times 2 is going to equal 4. And so the square root of 4 is 2. And I can see that visually for any square that's got nice, easy whole number sides like this. This one has side lengths of 1, 2, 3, and an area of 9. And so the square root of 9 is 3. And I can start listing these over here. I know the square root of 4 is 2. And I know the square root of 9 is 3. And I can go on and do a few more of these. I'll do one more. 1, 2, 3, 4 by 1, 2, 3, 4. This has side lengths of 4. And there are 16 squares in there. So the square root of 16 is 4. Some of you may have noticed a problem here. The square root of 4 is 2. The square root of 9 is 3. So we don't have any whole number side lengths between these two to answer questions like, what's the square root of 5? What's the square root of 6? And that's because those don't have nice, simple whole number answers. Most of those will be irrational numbers. There are a few situations in which you will get some interesting decimals. But in general, it's going to be, if it's not a perfect square, it's going to be an irrational number, which means it's not going to fit nicely on our grid. But you can approximate it. So if I know I want to find the square root of 8. Now, I already know 3 is too big because that's the square root of 9. 2 is going to be too small because that's the square root of 4. So it's going to be a number between 2 and 3. So I can use a guess and check process if I want to find this by hand. I'll start by doing 2.5 times 2.5 and see what that gets me. I'm going to use a calculator. You could do this longhand, but I don't think that's a particularly interesting task for you to watch me do in this video. I get that 2.25 times 2.25 is 6.25. So this is an example of something, like I said earlier, that would be kind of an interesting decimal, because we now know that the square root of 6.25 is going to be 2.5. So there are some interesting decimal square roots like this out there. It just doesn't help with the particular question we're asking right now, except that we now know we need to try something bigger than 2.5. So I'm going to try 2.8. I've just picked something between 2.5 and 3, and I'm going to guess and check again. 2.8 times 2.8, and I get 7.84. So I found another kind of interesting decimal square root situation, but it isn't exactly what I need. So I'm going to go ahead and guess and check and try something else. I'm going to try 2.9. 2.9 times 2.9 is 8.41. So now I've narrowed it down. I know that 2.8 is too small and 2.9 is too big. I'll try 2.85. That's a little too big, but I'm getting warmer. I'll try 2.83. Ooh, definitely getting warmer here. But still a little too big. I'll try 2.82. And that's a little too small. But I'm definitely getting warmer. I now know it's between these two numbers. And so I could keep on doing this process indefinitely. But what I know is this is going to be an irrational square root. It's going to keep going on forever without terminating or repeating. So instead of doing that, at this point I am just going to ask the calculator, hey calculator, what's the square root of 8? On this particular calculator, my square root symbol is the one I hit the second button for over the power symbol. So I can just hit that. Oh, I have to put in the number first in this one apparently. And then hit square root. Oh, it's over the x squared symbol. I know how to use this calculator. Sure I do. I hit second, I hit square root, and then I put in my number. And I find out that the square root of 8 is, yeah, it's pretty close to where I was guessing. It's right in between these two. The next decimal I would have needed was to get this 8 and then a 4 and so on. And it's going to keep going even further than this. And so I just need to decide how precise I want it to be for this problem. So that's just a little bit about squares and square roots.